In this video, we will be learning about the fundamental principle of multiplication. Before getting into the main topic, let me give you an example, a problem to solve it yourself so that you get a good idea. So let's say we have a friend Peter. So this is our friend Peter and he needs to go to the market after returning a book to the library. Let's say to reach the library from his home, there are two ways. Let us name them way 1 and way 2. And to reach the market from the library, there are three ways: way 3, way 4, and way 5, right? So my question is, in how many ways can Peter reach the market after returning a book to the library? For example, to reach the library, Peter could choose way 2, and then to reach the market from library, Peter could choose way 4. So how many such possible cases are present in which Peter can reach the market after returning a book to the library? So pause the video right now and jot down all the cases that comes to your mind. So let us start solving this problem. So let us name the two jobs that Peter has to do over here. So there are two jobs. First, going to the library from home, and another job is going to the market from library. So let us name these two jobs. First, going from home to library. Let us name it as job A, and it could be done in two ways. Two ways, right? And there's another job which is going from library to market. Let us name it as job B, which could be done in three ways. Now let us tabulate all the possible cases in which Peter could reach the market. So let's make a table. So here in the left hand side, I am writing job A, and in the right hand side, job B. Remember, in the context of this example, what job A and job B means, it's written over here. So let's say for doing job A, Peter chooses way 1, and for doing job B, Peter chooses way 3. Another case could be Peter chooses way 1 to do job A and way 4 to do job B. Another case could be way 1 is chosen for doing job A and way 5 is chosen to do job B. So if you notice carefully, then you would find that these are all the possible three cases where job A is done with way 1. So let me write three cases where job A is done with way 1, right? Now let us write down all the cases in which job A is done using way 2. So job A is done using way 2, job B is done using way 3, way 2 is chosen for job A, way 4 is chosen for job B, way 2 is chosen for job A, way 5 is chosen for job B, right? So here as well, these are all the possible three cases where job A is done with way 2. So these are the three cases where job A is done with way 2, right? So if you count the number of cases that arise of Peter reaching the market, you would find that there are a total of 6 ways that Peter could reach the market after returning a book to the library. So in this context, in the context of this example, it's quite simple to tabulate all the cases, right? But there are several problems in permutations and combinations in which you have to deal with a lot more cases, and in those problems, it is really inconvenient to tabulate all the possible cases. There's where the fundamental principle of multiplication makes our life simple. So let me write the statement of fundamental principle of multiplication. So we have the fundamental principle of multiplication. So the fundamental principle of multiplication, the statement says, if jobs J1, J2, J3 all the way up to Jn can be performed independently. This word is very important. Independently in M1, M2, M3 up to Mn ways. So up to this much, what this statement says is that if there are jobs J1, J2, J3 all up to N which can be performed independently, so the number of ways in which one particular job is done is not affecting the number of ways in which the other job is done. So if J1 can be performed in M1 ways, J2 can be performed in M2 ways, J3 can be performed in M3 ways, all up to Jn could be performed in Mn ways, then all jobs can be performed in succession in, let me change color, M1 multiplied by M2 multiplied by M3 all the way up to Mn ways. So if there are jobs J1, J2, J3, Jn that could be performed in M1, M2, M3 up to Mn ways independently, then the jobs together in succession, one after another, could be performed in M1 multiplied by M2 multiplied by M3 multiplied by all up to Mn ways, right? So it's a bit tricky to understand from the statement. So let me take Peter's example again. So here's again our friend Peter. So in the above example, we had two jobs, right? We had two jobs. Job A, which could be completed in two ways, and job B, which could be completed in three ways, right? And one very important thing to notice over here is that these are independent of each other. So these are independent of each other. By independent, I mean that the number of ways in which job A could be done is not affecting the number of ways in which job B could be done, right? So these are independent. You do one job, then you freshly start another job instead of worrying in which way you did the job A, right? So there are two jobs independent of each other. The first job could be completed in two ways, the second job could be completed in three ways. So number of ways of doing job A and job B. Doing job A, and since we are doing both the jobs, right? We have to do both the jobs to reach the market. Job A and job B is So by the fundamental principle of multiplication, it's the product of the number of ways of doing the jobs independently. So it's 2 multiplied by 3, which equals 6 ways. That's it. What we had to tabulate all the possible cases. We are just using the fundamental principle of multiplication to find it directly. So let me give you another example, which is a little bit tricky one, so that you can understand the real importance of the fundamental principle of multiplication. We have this problem over here. Let's try to solve it. A room has 12 doors. So a room is having 12 doors. In how many ways can a person enter the room through one door and come out through a different, not room, it's a different door, right? So our room has 12 doors. In how many ways can a person enter the room through one door and come out through a different door? So let me try to explain the question first. So here we get the solution. Let's try to understand the question first. So we have a room. Let me draw a room. Great. So there are 12 doors. Let me draw 12 doors. It's 1, it's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So there are 12 doors. Now the question says that if a person enters through one door, let's say you chose to enter the room through door 1, so you are now inside the room. So you have chosen to enter the room using door 3, right? Door 10, not door 1, so door 3. Now you can't exit or come out of the room using door 3, but you can come out of the room using any other door that's possible. That is 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, excluding door 3. So there are two jobs, right? One is entering the room and the other job is to come out of the room. So let's write over here. There are two jobs. One is job of entering the room. Let's name it as job A. So how many ways are there for doing job A? For entering the room, you could choose any of the doors, right? So there are a total of 12 ways of doing job A, right? Then the other job is to come out of the room. So it's job of coming out of room. It's gonna be N M. Okay, so let's name it as job B, right? So how many ways are possible for you to come out of the room after you have entered the room? After you have done job A, there are 11 ways, excluding the door that you chose to come inside the room. There are 11 other doors through which you could get out, right? So there are 11 ways of coming out of the room after you have done job A, right? So did you notice over here, these are independent job. It doesn't matter whether you come inside the room using door 1 or door 2 or door 3, there will always be 11 other ways of coming out of the room, right? So these are two independent jobs, job A and job B. One is of entering the room, the other is of coming out of the room. So using the fundamental principle of multiplication, we can say a very apt statement. Let me write over here. Therefore, number of ways a person can enter a room with one door and come out through other in a room with 12 doors is equals to, using the fundamental principle of multiplication, it comes out to be number of ways of doing job A multiplied by number of ways of doing job B. So what is it? It's equal to 12 multiplied by 11, which comes out to be 132 ways. So did you notice, if you had to sit down and count all the cases, you would have to count a total of 132 cases. But this hectic job is made simple simply with fundamental principle of multiplication. So that's how you can solve lengthy problems easily in a few seconds with the fundamental principle of multiplication, and it could be also generalized for n number of jobs. I have taken 2 jobs for giving you an example. So this is all about the fundamental principle of multiplication. In the next video, we'll be learning about the fundamental principle of addition. Till then, that's all.